Hello, here let's talk about chapter 7.1, Radian Measure. So a circle is 360 degrees for your circle, but for the circumference is equal to 2 pi r. But if we make this a unit circle such that the radius is 1 unit, then your circumference is simply 2 pi. So we're going to use that and say that the circle, one definition of a circle is that it is 360 degrees, and another definition for the unit circle is that it is 2 pi radians. So the three dots in the triangle configuration like this means therefore. The other way it means because. So therefore, 2 pi radians is equal to 360 degrees. Okay, this implies, so if I were to divide both sides by 2, this implies that pi radians is equal to 180 degrees, so that this ratio is equal to 1. And when you multiply something times 1, you're not changing anything. And this concept we will use coming up. Okay. So over on page 477, problems 1 through 4, these say use the definition theta equals the side length divided by the radius to determine the radian measure of each angle. So the proof of this I put in this week's module 7.1, proof of arc length and area of a sector video. This was done by YouTuber Black Pen Red Pen. I like some of his videos as well. I've liked all of his videos. He does good stuff. And so for problem 2, we need to find the radian measure. Okay, so theta equals the side length divided by the radius. So this one's going to be theta, and it's wonderful if you can write your formulas down as you use them, because then the more that you write them down, the more they'll go into your memory. So this implies that theta is equal to 2 centimeters divided by 3 centimeters. The units simplify so that theta is equal to 2/3 radian. You can also say theta is equal to 2/3 RAD, and I have seen it also as just plain 2/3 without the units at the end, but I would ask you to do one or the other. Include your units. Okay? All right. This next one here, we have theta is equal to the side length divided by the radius. So this implies we have theta is equal to, so here the side length is in meters, and our radius is in centimeters. So it does not matter, technically it doesn't matter which unit you end up with, but the units have to agree. And so let's make these into meters. Okay. So I'm going to multiply it by a funny looking 1. The same non-zero number divided by itself is equal to 1, and 100 centimeters is equal to 1 meter. What this will do is the meters will simplify, the centimeters will simplify, and we will get the proper number. And this is the numerator, 0.0367 times 100, and then divided that by 1.0013 to give me 3.665. Okay, and the units, these are radians. So for these 5 through 8, these say convert to radian measure, express your answers both in terms of pi and as decimal approximations rounded to 2 decimal places. Okay. So 30 degrees, what we can do, since your degree is on top, we're going to multiply this by because pi radians is equal to 180 degrees. So multiplying anything by 1 doesn't change it. Your degrees are on top, multiply it with the degrees on the bottom. Now the degrees will simplify each other out. And 30 divided by 180 is 1 over 6. Okay. 150 degrees, multiply this by a funny looking 1. So this is going to be 15 over 18. And 15 over 18, this is, so break this down to a product of primes. 15 is 3 times 5. 180 is 3 times 6. So this gives me if I make a mistake, please let me know. So this one's going to be 30 over 18. So 30 is 3 times 10, which is 3 times 2 times 5. And 180 is 2 times 3 times 3. Okay. For 8a, it's the same thing. Okay. So this (36) is 4 times 9. Is 2 times 2 times 3 times 3. And 180 is 2 times 3. So there's 9 times 2 and then times 10 times 2 times 5. So that we have 3 pi radian, 3 pi on the top, divided by wow, no. 36. 4 times 9. 180. Because that is. So in the numerator, denominator. $35 is 7 times 5, and 180 is a familiar one. So there are a couple of ways that you can approach this. This is one way. This is not finished yet. But remember, one entire circumference is 2 pi. One entire circle is 360 degrees. So if you had 720 degrees, that's simply two revolutions, but you would end up at the same point. Likewise, with 4 pi, there's 1 pi, 2 pi, 3 pi, 4 pi. You would also end up at the same point because you can either add or subtract any multiple of 360, or you can add or subtract any multiple of 2 pi. And so 4 rad is the same thing as you end up with 0 radians. Additionally, if you wanted to, so you can either start with 720 degrees or start with 0 degrees. 0 degrees, you'd get the same result. Number 9212, convert the radian measures to degrees. So 3 pi, we can subtract 2 pi from that. We would have the same terminal angle. So to convert to degrees, so now with pi on the top, and it's not just a pi, it's the absence of degrees, which maybe you'll see here coming up. It's the absence of degrees. So let's introduce degrees at the top. Okay. So here is the absence of degrees. So for these ones, find the arc length S in each case. Okay. So with these, we'll still have theta equals S over R. Except now we're just missing this S. And I sometimes add that little hook at the bottom of the S to show it's an S, not a 5. All right. Okay. Including your proper units, we'll make sure that your proper units will be in your final answer. Yes, this is longer than 2 pi, but your radius is also longer than 1. So your theta needs to be in radian measure, not degrees. So let's convert this to radian measure. We have 15 over 18. 15 is 18 is that's our radian measure. Is equal to the side length we don't know, divided by the radius. This radius is 1 inch. Thank you very much. Please go to tutoring